Hello and welcome to another video. We are continuing with our past paper 9709 February March 2023. The variant of the paper was paper 12. Today we are going to focus on question number 10 of the same set paper. In this question, we are given with a curve and a point on the curve is given, which is 4 minus 1. The gradient of the curve is minus 3 by 2 at this point. The equation of the gradient dy by dx is equals to x to the power of negative half plus k, where k is a constant. We need to show that k is equals to minus 2. I will give you some time. Try to solve this paper, pause the video, then we would continue. I hope you have tried this question. Let's start. Since dy by dx is equals to x to the power of negative half plus k, we would equate it to negative 3 by 2, 4. So if we rearrange it, it would become 4 to the power of negative half plus k is equals to negative 3 by 2. Now 4 to the power of negative half is 1 over 2 plus k is equals to negative 3 by 2. So it would become k equals to negative 3 by 2 minus 1 over 2, which is equals to negative 2. That is shown. In part B, we need to find the equation of the curve. In order to find the equation of the curve, we would be integrating this differential equation. So our equation was dy by dx is equals to x to the power of negative half plus k. So x to the power of negative half minus 2. Remember, we would be using these 2 points as well in order to find the constant of integration. So I'm going to write this point as well, 4 minus 1. So dy by dx is equals to x to the power of negative half minus 2. Since anything raised to the power of 0 is 1, I can use this concept and write this value. So this is our equation. Now, what was the rule of integration? Add 1 to the power and then divide the sum. So it would become x to the power of negative half plus 1 minus 2 x to the power of 0 plus 1. And obviously this would be divided by minus 1 over 2 plus 1 is 1 over 2. So it would be divided by 1 over 2 and it would be divided by 1 plus c, which is constant of integration. And obviously dy by dx when integrated with respect to with respect to x or dx, it would become y. Now if we simplify it would become y is equals to x to the power of half minus 2x plus c. Now we are going to plug this point. The value of y is negative 1. So negative 1 equals to square root of 4 minus 2 times 4 plus c. So it would become minus 1 is equals to 2 minus 8 plus c. So it would become minus 1 equals to negative 6 plus c. So it would c is equals to 5. So our final answer would become y is equals to square root of x minus 2x plus 5. This is our equation of curve. That's our answer. Okay, in the next part we are asked to find the coordinate of stationary point. How would we find the coordinate of stationary point? Again, we are going to use the equation of differential, equate it to 0, find the value of kx, put this value in the equation of the curve we found in part B. We would start with the equation of differential. So dy by dx is equals to x to the power of negative half minus 2. This would be equals to 0 as already discussed. So it would become x to the power of negative half equals to 2. So 1 over square root of x equals to 2, and x would become 1 over 2 is equals to square root x, and x is equals to 1 over 4. Now we are going to plug this point back into the equation we found. Remember, we have to plug in this equation, not in the derivative equation. Why? Because if you plug into the derivative equation, it would become 0. And this would be dy by dx as 0, not y is equals to 0. So coming back to the point, y is equals to square root x minus 2x plus 5. Y is equals to square root of x minus 2x plus 5. So our value of x was 1 over 4. So y is equals to square root of 1 over 4 minus 2 by 4 plus 5. So it would be 1 over 2 minus 1 over 2 plus 5. So they get cancelled. So y is equals to 5. So our coordinate of stationary point would become 1 over 4 comma 5. Okay, in the next part, we are asked to find the nature of stationary point. What we are going to do? First, we are going to find the second derivative, d2y over dx squared. Plug the value of x in from here into this equation and then check if it is greater than 0 or not. We have dy by dx as x to the power of negative half minus 2. Now d2y over dx squared. This, what does that mean? It means the second derivative of the first derivative. So what was the rule of differentiation? Bring the power down, subtract 1 from the power into the derivative of x, which is 1 again, minus 2 to the power of x, which is 0. Again, if we bring this 0 down, it would become multiply by 0. So anything multiplied by 0 is 0. So the derivative of this thing is 0. So our d2y over dx square would become negative half into x to the power of negative 3 by 2. Now what was the value of x? 1 over 4. Straight away you can see it as well that the sign is negative, and if we have negative 1 over 2 into 1 over 4 to the power of negative 3 by 2, so it would become negative 1 over 2 into 1 over 8. So it would become negative 1 over 16, which is lesser than 0. So whenever d2y over dx squared is lesser than 0, then the root is maximum. The stationary point is maximum. That's it.